What's going on, guys? It's Cooper Codes, and in this video, I'm going to show you TypeScript classes in 10 minutes. We don't have much time, so let's get into it. Alright, so for this video, I'm just going to open an empty index.ts file to just put some TypeScript code in. An important concept to understand in this video is that TypeScript is pretty much just JavaScript, but with types. And coming with types means you're also going to have classes. In order to define a class in TypeScript, you just use the class keyword like this, and then whatever name you want to define. In this video, we're going to be making a person class as our main kind of base class. We can then define the variables that we expect our class to have. For example, a person is most likely going to have a name, which we can define as the type string. Classes also use a thing called constructors. A constructor gets used when you do something like this. Let person1 equal new person. You're then going to have these little semicolons at the end. These represent that a constructor could be used. Right now, our constructor is the default, which is no parameters. But if we want to define a constructor where we have a person's name, for example, we can say constructor name, which is going to be a string input from the user. And then we can set the name of this person. So we can say this.name, which is going to reference the name at line 4, is equal to name. And that name is going to be the one that our person passed in. And check this out. We're now getting an error over here. This is because our constructor now requires you to have a name input. So we can make this person's name called Cooper. And so now we can console.log the person1.name. In order to run my TypeScript code, I'm just doing npx ts-node index.ts. This is a command that uses a node package manager to pretty much help us run TypeScript stuff. I'm pretty sure you don't even have to install anything to run this. And as you'll see, we now have the person1's name. An important thing to understand when you have properties like this is we can now do something like person1.name is equal to Thomas. This is an issue because sometimes you don't want the user to be able to change these variables. And so let's see if it's going to show us Thomas on that second console log. So depending on your use case, this couldn't be good for a couple of reasons. The first one is that we have totally forgotten that the name was ever Cooper. So if you have data inside of your class that you want to, keep for a long time, and then the user can just change it, you lost it forever is a way to think about it. Let's say that we want the name here to be 100% private. We're now not able to access the person1's name. But what if we still want to be able to say person1.name and get that value, but we never want to be able to change that value? We can use a property called read-only. Read-only is totally chill with you getting person1.name and it's still going to show Cooper, but it's not going to allow you to change the value of the name. You could kind of think about it like a constant name, but remember, the read-only value can still be changed within your class. But outside of the class, we're just going to see the same name over and over. So private and read-only are important when it comes to thinking about what data the user can access from your class. We can switch name back to a regular public property of person. By default, these variables are always going to be public. And so let's just say a person can have a certain job title, which we can do by saying job title is string. So another just simple public variable. We can now make a class that extends the person class. An easy way to think about this is think about a thing that needs to build upon the functionality of a person. For example, we can think about a certain employee. In this case, I'm going to use a janitor. A janitor is going to have all the functionality that person has. They're going to have a name, they're going to have a job title, and imagine you had a very expansive person class. A janitor would still be a person and have all those different attributes. This janitor class is going to require a constructor. And so if we wanted to make a new janitor, for example, instead of saying new person, we would say new janitor here. And so we can say, okay, if we want to say new janitor, we still want the name of the string here. So inside of here, we can call the super constructor. This is going to give us access to the constructor of the class that we're extending. So for example, this super keyword here is going to look over at line 8 and look at this constructor. So right now it has one parameter, which is just going to be that name. For our case, we also want to be able to access this job title. This means that we have to change the constructor at line 8 to have a job title input. This is because we have to be within this class to change the value of job title. We can change the value of job title by saying this.jobTitle, which is referencing line 6, is equal to the inputted job title. So now you'll see the super constructor has an error. This is because it's now expecting that second job title argument. For our extended class, we can manually set a value here. For example, I'm going to set it to the value of janitor. This new functionality gives us access to two things. When we create a person, we can also give them a job title. So I can say Cooper is a programmer. And now we can also initialize janitors. So I can say let janitor1 be equal to a new janitor. And you'll see this constructor is only going to have one parameter because when you make a janitor, for example, it's looking at the constructor at line 15. So we just need to put in the name of the janitor. I'll just say something like Bert. And so if we were to console.log the janitor1.name and also console.log the janitor1.job title, we're going to see that it is our constructor here that is setting the value of janitor. We don't have to say janitor inside of the we don't have to say janitor when we call the new janitor at line 24 because our constructor is setting that value for us. And so we can see that value here by running our code, and we can see that the janitor's job title is being set by our constructor here, so it knows it's a janitor, which is super great. We can also add on properties to our janitor class that are unique to janitors themselves. For example, let's say we had some type of system where it was important to see if a janitor was working at a school or working at like a different, institution. We could make a works at school Boolean as a property of the janitor class. I know it's kind of a strange example, but I want to show off what using a Boolean would look like. We could then add on to the constructor of our janitor class. We could ask the user to input a works at school Boolean whenever they make a janitor, for example. So on top of our super constructor, we can also say this.worksAtSchool is equal to whatever the user inputted. And so you'll see down at line 27 now we're going to have an issue. We need to say if Bert the janitor works at a school or not. So I can pass in true. And we can also console.log that property here. We can say, okay, do they work at a school? We can run that code and it's going to say true, which is pretty cool. Let's say we had a janitor that wasn't working at a school. We can do the same thing by changing this to false. And the code's going to show that the janitor is false, which is great. We can also make functions which are unique to a certain class as well. For example, mop the floors is going to return nothing because I'm just going to do a console.log and I'm going to say console.log, I'm cleaning the floors. I know these examples are kind of dumb, but these are great examples for if you were to implement your own logic. You can imagine, I have a class and I wanted to have its own function. This is how you define it. And I defined void here because we're not returning anything. If I wanted to return instead of console.log, I could say string here and then just return I'm cleaning the floors. Just to give you guys an example of that. And so now if you want to see what it looks like to call a method of a certain class, we can say janitor1 dot mop the floors. And that's going to console.log I'm cleaning the floors here. So this is pretty amazing. We now have an extended class in TypeScript that has its own unique property to a janitor and its own unique method to a janitor. Here's something to think about though. What if we wanted some type of very, general kind of functionality where we know every single person has some type of action they can do? We can say, okay, I want a function down here and I want to, do current action. So I'm being very vague about the naming of this on purpose. And I'm going to show this error on purpose. Function implementation is missing. We need to make the person class an abstract class. Abstract classes are amazing because they allow us to use the abstract keyword. The abstract keyword means we don't need to define the function here, but if any of these classes extend person, for example, those classes need to define it, which is why we're running into an error now, is because janitor doesn't have a do current action. It's saying, hey, I'm looking for a do current action and needs to return a string. So I can go down here and say, okay, I can define do current action like this, and I want to make sure the return types are the same like this. And I can return the string by saying return, I am cleaning the floors. And so this is really interesting because it allows our extended classes to kind of follow a format. It's one of the amazing things that abstract classes allow us to do. If we know that any class that extends person needs to have some type of method, then we can use the abstract keyword to say, hey, we know that this method needs to exist, but we don't know what it should be if we're just a person. If we're a janitor, though, we know that our current action is going to be something like cleaning the floors, for example. And line 34 is letting us know something super important. You're not allowed to directly define an abstract class. Abstract classes are pretty much missing out on functionality. They need to be extended if you want to use them. Because right now, do current action, the abstract keyword saying that this function needs to exist, but it doesn't currently exist. And so that's the issue you run into with abstract, is that, for example, you can't define a person by itself. And so just for practice at the end of the video, I'm going to define And so just for some practice at the end of the video here, I'm also going to define a programmer class. We can start by doing the same thing and saying class programmer extends person. One thing we can do is we can say constructor. I'm going to get an inputted name from the user so we can name our programmer. Then we're going to call that super constructor like I talked about before. The super constructor is right here at line 8, and so it takes in a name and then a job title. I'm going to put the inputted name from the user here, right here, and then I'm going to manually put in the programmer job title. You'll see I still have this little red line here because we don't have do current action. Remember, because we're extending an abstract class, we need to have this do current action be defined. And it also needs to return a string. That's another important part. So I'm going to define do current action returning a string here, and I'm just going to say return, I am working on the code base. So we can go down here and initialize a programmer, for example. So I can say let programmer1 equal to new programmer, like this. Just going to take in a name, which I can say is Cooper. Then if I console.log the programmer1.do current action, this is going to allow us to see the current action of the programmer. So we can go and run our code. Our do current action is now specific to saying I am working on the code base because it is a programmer extending the person class, which is pretty cool. Hopefully this video was a good introduction to TypeScript classes and it got you up to speed pretty fast. Classes are something that you learn so much about by just working with them and kind of understanding why you need certain things in your class. Understanding class structure as well is something that's even debated among great programmers. And so hopefully this video was a great overview. All right, thanks so much for watching.